Well, thank you very much for being here, and thank you for having me here. It's an honor. Um, Today I want to talk to you about a personal project of mine, and it's about the high-frequency cryptocurrency trading using Asyncio. First, something about myself. I've studied methods and statistics. It's a research master. I find it a very good foundation for data science. I'm also Intel AI innovator, which means that I use Intel products, and yeah, I'm an ambassador for them. I get to play with the latest AI tech of them. I love open source a lot. I also love innovation, so I don't only do data science, but I've also been interested in blockchain, IoT, and all the other hypes. And also, I'm very interested in the human and machine interaction. You can see a robot here as an example. You would not imagine how many things can go wrong with a robot, actually. Like Wi-Fi not working, broken cables, suddenly no sound. Yeah, but it's a lot of fun. And well, I'm a lead data scientist at Jibes Data Analytics in the Netherlands. There's 35 data scientists currently. I've worked there for 4 years, and in that time I've been to 15 different companies to help with data science problems. But yeah, like I mentioned, I'm also interested and worked on blockchain, social robotics, natural language processing, machine learning, deep learning, all those kind of things. And recently I was at EuroPython with a presentation when to use machine learning. So this is my open source page on GitHub. I also have a blog on github.io, and yeah, maybe you've seen some of these modules, but yeah, these are the kind of things I've created. As you can see, it's all Python, so yeah, I really enjoy programming on these kind of yeah, hobby projects. Okay, but today we are about the cryptocurrency trading, and so I want to first explain to you what cryptocurrency is and kind of how trading works. How I started, then we'll get into some Asyncio details, the high frequency part of it, but also about the stabilization and running it in production. And in the end, of course, everyone is interested in the profits of such a system. So I just wanted to kind of say where this is coming from, because I never thought I would be actually, doing any of this. I used to play a lot of AI games. You program a bot for it. So, for example, the poker bot that you see on the top left, or like a Tron game, or like Risk or Warlight. And I'm one of those people that really enjoys meta gaming, meta play. So it's more interesting to talk about what could have happened, or like what would be a good strategy, than to actually play. So that's the type of person. But the cool thing with these competitions is that it's a very clear score or measurement of success. So you can have bots play against each other, and the computer can run thousands of games, and yeah, it's really fun for me. But yeah, so how did this lead to the cryptocurrency? Well, I think that the interesting part is with the cryptocurrency is that it has a real base of measurement, which is how much money did you earn. Well, I don't know, anyone here familiar with cryptocurrencies or has been trading? Or maybe raise your hands. Yeah, okay, about half. Yeah, I never thought I would be interested in it. I've been interested in blockchain for a long time, but I never thought I could do something like that. Like I never thought it's possible to make something work. And that's because, well, when you do the trading, I always imagine, you need some really strong machines. You need to have a really short cable to minimize the delay between the exchange where you're trading and your bot or whatever. The commission for trading is very high, and data is very expensive to get. So I thought that, it's not possible to do any kind of trading. I mean, I'm a data scientist. I want to analyze anything. I considered doing something with stocks, but it doesn't make sense from a personal perspective. But yeah, then comes cryptocurrency, and just very brief it's kind of like e-currencies. So it's all virtual currencies, and the most notable one is Bitcoin. But what you'll notice is that it was an unregulated field, so a lot of things can go wrong here. Like there's no government making sure that things are working, or like no cheating going on, or anything else that just breaks. So I have an example that I obtained a few ethers, and what happened to me was that I lost them. So the actual thing was that at some point the value would have been $30,000. I got them when they were 200. But yeah, I posted recently when the price was that high. I posted on Reddit like, okay, guys, I lost the ether. It was like you had to fill in a form online to do some kind of transaction, and I filled in a field wrong. Like it had a placeholder, you know, those kind of gray things in a form. So I thought I already filled in where to send my money to, but they didn't do input validation, nowhere, not in the contract, not in the form. So I actually sent it to a 0 address, and that actually means that your money is gone. So there's no way, you know, I thought maybe, because that happened 2 years ago, I thought 8 months ago, maybe there's now something possible, but no. So that money is gone for good. But yeah, now let's get to the trading part of it. So there's like 2,000 of these cryptocurrencies. And their value fluctuates related to belief that people have in this kind of coin. You can see in this example, the price can really fluctuate like 15% on a day or something like that. Well, these coins are tradable on exchanges. So that's like a broker where you say, I want to buy a coin, and then they will make sure the buyer and the seller match. And they usually have an UI, but also an API. So that's the interesting part, right? Like you can completely automate the whole buying and selling. And there's multiple exchanges around, and each provide their own API, and each offer different terms, like how much commission do you pay, but also how well is their API done. Like only one of them or something has a test client. What is also funny is is that, you know, there's there's Bitcoin, but there's a lot of other ones as well. Just searching on Bitcoin shows how many there are. And you know, the funny thing is that usually these are people that just clone the Bitcoin code, change a few things, say that it's so much faster, even giving up security, and then it's claimed to be a new thing, and people put millions in it because it's a new big thing. It's really ridiculous. Luckily, there are some better coins that are really doing more research and actually are proving blockchain. But yeah, it's a funny thing always to me. Well, let's go to the trading part. So there's the fundamental trading, which says every coin or every stock would have an intrinsic value. So and you use the financial information of like last year, the year before, reports on it, and like that to determine if it's undervalued. If it's undervalued, you want to buy it. If it's overvalued, you want to sell it. And it usually goes on for longer term. Then there's the technical one, which is saying, okay, you know, all you need is the price data. So the historic price completely determines, or for a big part, what the future price is going to be, and that's usually more short term. So like this is an example. They would usually look at like a pattern, like you see like one called hammer or something, and then, you know, there's people with the UI like, that happened, so now I'm going to buy. But yeah, it's a bit funny to me always. Yeah, so like they always like to draw lines on the graphs to say, yeah, like, you know, this is proof. These lines, that means buying. Well, when I see this one, I also want to buy for sure. Then there's another one, which is the arbitrage, which is if the price for Bitcoin is $6,000 on one exchange, but it's on 5,800 on another, then you can buy it at one and sell it at the other. That's kind of arbitrage. But then there's actually a fourth, which is based on events. So, you know, the news has an influence on the price. So for me, that's a very interesting one. So, you know, like maybe, yeah, well, Let's look at an example. So I guess you can go. You can understand where I'm going with when you see this. So you see your price graph. You know, the price, it really jumped up, and it's interesting to know what happened. So this is the thing that happened. Microsoft announced that they're going, someone announced that Microsoft and IOTA are going to work together, basically. So what happened is that the price, it got 524 upvotes on Reddit, for example, just to give an idea, and it was on in November last year. And well, this is the price kind of around the time it happened, so it's like 125, and it went to 550, so like 400%, like 4 times increase in a few days. But then, as you can see on this spike, then someone posted on Reddit, that there's no that Microsoft is not confirming this. So it was just someone actually who created the fake news, and well, you can see what happens to the price afterwards. So yeah, you can see that there's positive events that increase the price and negative events that decrease the price. Well, this is then a result actually of my trading bot last week. You can see that over the course of 4 minutes, actually I earned 37% on a percentage of my amount of Bitcoin I had. So it can go that fast. Okay, so now to explain how did I get there to this kind of trade. So it started with me analyzing data to find the tradable events. So for example, you know, the Microsoft partnering with, that's like a really, where you would see that happen in the news, pretty much everyone would consider that a reason to buy it. So yeah, you want to analyze really the data to see if there's a way you can find the patterns in it. Then actually I created a Slack bot for it. So that it would send me, or it would send to a Slack channel a message like, okay, you know, this is an important thing. I put some filter on it, like if Microsoft is in the, you know, text and partnering, for example, then I would get a message in my in the Slack bot, and then I could say, okay, you know, yeah, maybe buy on that, you know. So yeah. What I collected was data like Reddit, Twitter data, and also pricing data. So then you can kind of see if there's an overlap. You use data science things for it, searching for patterns. But yeah, so to talk about the interactivity of it, I created a Slack bot. I actually had a way that I would just have a buy route for the thing I was running. Where I could say, okay, you know, I want to buy the IOTA that was mentioned before. I just have to call /buy, and wherever I have my coins, it will first convert them to Bitcoin if it's not already there, and then it will just buy the IOTA. Similarly with the sell, you know, it would convert it back to Bitcoin. So I integrated that in a Slack bot, just like, for example, okay, what is the current price of something, and like, you know, like what is my balance? You know, it's just having fun with these kind of things. Like, what can you do with a Slack bot? But kind of the problem was that, like, by the time that I would get the message or I would be notified, the price could already be up by 20% or more, or, you know, it would have already been over. Like, that could happen so quickly that, you know, that it's pointless. I thought about, you know, maybe I invite some friends and we are all, you know, going to follow that Slack channel, but yeah, that's crazy. So so I thought, you know, okay, trading bot, let's automate the whole thing. So I don't know if everyone ever needed high frequency transaction speed. I don't know if like it's like a millisecond slow or fast. I know. Does anyone have like has to be faster than a millisecond? Raise your hands. I guess not no one, right? So Yeah, well, I never thought I would need that as well, but now it becomes interesting. You know, I always thought, yeah, why would you need this kind of speed? Python is fine. But yeah, so the challenge here is actually we want to be as soon as possible when the signal is there. We want to be responding to that as fast as possible. We want to determine a maximum price that we are willing to pay for it. Then you want to shoot the message to the exchange as fast as possible, like I want in. And well, after you got it, you have to determine when you're going to sell. So that's kind of the challenge. And so actually now it gets to be engineering programming problem, right? Which is fun. And interestingly, I did an analysis on code on GitHub and noticed that the clients or the exchanges clients are actually mostly written in Python by everyone. It's like one of the best supported things, and yeah, I will get to that why that's the case. So what is actually the challenge is doing multiple things at the same time, because yeah, we need to do multiple things like monitoring certain websites, Reddit, Twitter, other websites, but having pricing information, and like there's a lot of things you want to do, and you want to do them all in the same time. If it would be CPU bound, then for doing calculations, natural language, machine learning models, you would use multiple processors most likely. But when it's I/O based, which most of all the actually all of this stuff is, you can use multiple threads, or you can use async I/O. So I never liked the threads interface, so I thought, you know, let's give async I/O another go. I tried it before, but yeah. So I don't know who already used async I/O here. I guess half. Again, I never thought I would need it really, but here I am. So just a quick idea on like the benefit of async I/O. Normally you prepare a request. I don't know what kind of calculations you have to do. Then you construct a URL, you construct the data you need to post, or like when sometimes that's managed away for you. But you do some preparation. Then you go into a state where you're saying, okay, send this to a server, and you're waiting for a response. Server or a website, a database, yeah, you're basically waiting for a network connection and the time it takes for a website to calculate your result and give you back the result. So that's what's happening in I/O, and afterwards you are processing the response again. So that's the things you usually do with like the database or website on your machine. Maybe create a view, or yeah, doesn't really matter. But the thing with async I/O is that while you're doing I/O, you can actually prepare and process other things. So whereas with, for example, the synchronous frameworks, you're waiting actually the time and the process blocks, and after you get the result, you can then process the result. So this is a kind of simpler. Yeah, my kind of explanation of async I/O, or why you want it. And I really recommend you watching this this presentation, because that is really the thing that helped me understand how to do it. So just yeah, like first sentence here is async can only be called by other async functions. That's kind of a strange thing, but yeah, you'll have to get used to that. And there's syntax for it in the current version, so that's really nice. Like, I don't want to talk about how really about how async I/O was, but now we have async def, we have await, async for, async with, and yeah, this is kind of what you would expect just with other Python, but then in the asynchronous version. So let's get to some live coding. So let's see, I guess I have to zoom in. I'm thinking maybe this is better. I hope it's readable. So let's evaluate the first part. Yeah, this is kind of a data scientist approach. So here we have asynchronous get. So basically we just want to get the price information here from the exchange. So yeah, you can see making a session, just like with requests, but then the asynchronous version, where you see here await, and also with the async lines, that means while this line is running, other things can actually also run. But you still have a guarantee, not with like JavaScript, that the next line is only going to run, you know, before the line before it finished. So let's evaluate them. So now in the most recent version, you can use async.io run to actually run the asynchronous coroutines. So for example, now let's see what happens. Okay, I think I didn't save it the last time, so there we go. So now what we did was actually run in async the getting a price information, but the thing is, yeah, we're only doing one thing, so there's no asynchronous stuff going on. So what we can actually do is actually run multiple things by using async.io wait. Like this. So now, okay, of course, have to be a list. So now they were actually running at the same time. See? So instead of having to wait for one and the other, it's actually running now asynchronously. So that means in the, yeah, remember first processing, then you have the I/O, and then, so it did the first processing, then you go into I/O, and while this first one is in the I/O, the other one is being prepared and going into I/O, and so that kind of, that's the order of how things are happening. But yeah, the cool thing is, so you can just add, can do other things as well, like you add a sleep in there. But yeah, it's not noticeable. Like the sleep keeps going on even though other things are running. So that's really nice. So there's another example. So we now did REST calls, but we can also do WebSocket stuff. So WebSockets allows the server to send data whenever it wants to you. So when you're doing a normal HTTP, you're asking a server to send you a result. In WebSockets, you're saying, okay, just whenever you want to give me a result, I will receive it. So that's what WebSockets do. So this is the WebSocket version of it. And the cool thing here is that you have this async for, which you can pretty much just understand. Oh wait, I'll zoom it in a bit. So you can pretty much see this as like something like this. So for example, right? So it's just a nicer way. So you can imagine still every time between those lines, it gives away control. But yeah, again, you just work with it synchronously, so you don't really notice it. Another thing to add here is that you could add a line where you authenticate with the server, so then afterwards you're able to send order. So yeah, let's run it. So yeah, here we go. Like now the server, whenever there's a change in something, then the server will send it to us. And so we can stack this, as you see, with, for example, sleeping, and it's not bothering each other at all. Okay, so that's another part. Now let's get to Twitter stuff. So this is the Peony is the asynchronous version of a Twitter client. So yeah, you can see here my hidden secrets. Let's say we want to follow Bitcoin, Ethereum, two of the cryptocurrencies, and here you use you see an async with, async for again, but let's just use it. So now we are getting tweets that are happening live. So if you're really quick, then you can just add one now here. Yeah. So yeah, pretty much this is the Twitter stuff. And so now let's combine it into one thing. So we see here UV loop. I'll talk about that. That's just this code, but we'll talk about it later. We have here a way of handling the pricing information. That's this one. This is also this is the subscription of it to the WebSocket, and we have a trading function. So what you can see here is we're combining the two things. We want to get pricing information, and we want to get tweets, and whenever we get a tweet, we want to, for example, trade. You can see here I've implemented a trading function like this. So it's like if the letter A is in the tweet, then we're going to buy it. It's a fantastic strategy. So you see here the pricing updates, you see tweets, and you see when we are going to buy and at what price. So pretty much you have everything for a really stupid strategy. But yeah, so I mean, obviously, you just need to implement this part better, in a more clever way, when you want to buy, when you want to sell, and that's it. But now you have all the pieces. Okay. So now I want to share with you some of the optimizations that I've done in the process to make it really fast. So I talk about the UV loop, my cloud choice, and the architecture that I used in this. So just having those 3 lines that I just showed you, using a different loop from UV loop, you're going to get 2 or 4 times faster, you're able to handle events faster. What you can also see is that the amount of requests you can process with using this, like it's implemented, I believe, in Python, is on the level of Go. So that's really interesting, because I mean, in the end, network stuff is mostly what we do, and you know, if we just use this, then I don't have to program in Go. I have mostly web stuff going on. I mean, basically, the only thing I have to do is to send a really tiny little bit of JSON to an exchange. That doesn't cost any CPU, it's just I/O. So I actually did try to see if I can make faster requests with Go, but the Python request is actually faster than my simple Go implementations, even with optimization. So, I mean, that should be obvious, but I just wanted to make sure. And then I also did a cloud comparison. So I compared Google, DigitalOcean, Amazon, a dedicated machine, and Linode. So the fun thing here is that I don't really care about CPU, but I noticed that it makes a big difference if I'm expecting news results in Japan, then I need to have a machine in Japan. It will be significantly faster. We're talking really like 10 times faster, 20 times faster. 30 times, like really ridiculously much faster if you're just in the right region. So with the thing of the short cable still holds, but you know, as a kind of an amateur, you can still get away with cloud stuff pretty well. I noticed that internet speed is great on Google on Linode. I noticed that the availability of regions was great in Google, but the reason why I didn't choose Google in the end was because for the $5 you get a virtual CPU. And at first I thought, okay, that doesn't matter. I get 20% of a CPU, but I barely need to do CPU. But the actual thing is that they're throttling you. So that just means every now and then they're going to say, okay, pause your process, another process can run. So, I mean, yeah, that is horrible, because that just means I'm going to have like a couple of milliseconds that nothing is happening. That's absolutely horrible. So that's the reason why I actually chose Linode in the end, because it does give you a full CPU for the $5. It had a good availability in the regions that I needed, and the internet was great. And this is no sponsorship, but maybe we should talk about it. Okay, so now let's go to the architecture. I actually, because it's mostly network bound and there's a lot of variation in it, I wanted to use multiple workers. I use 5 or multiple different machines. And then they coordinated with a thing in between that would say, okay, now we're going to buy. We don't want to buy too many times. But then I came up with a fantastic architectural breakthrough, which is like, wow, what if we just have all of them say, okay, we want to buy, and the exchange will just tell us, you don't have enough money to buy. So the first one will succeed and the rest just fails. So you have to change some things in your code to make that actually work, but it's really nice. Okay, so what else did I do? Like what I noticed is that you know, it's very useful to get notifications when stuff is down. I implemented thing that I get a real push notification to my phone, email, Slack. I did error tracking, centralized in one place that I can look at the errors using Sentry. I also realized it's very useful to do introspection, so that I want to say, okay, how long has this server been running? When did it visit last times these kind of websites, so I can make sure that it's not too slow. I will get notifications if something is wrong. So I also implemented a health check, a separate process that just does curls on this. So the cool thing is with the introspection, I just add another async server to the thing, which then can give me these kind of routes of is it up, since when is it up, yeah. So all this kind of information, you can easily plug it in. And the health check uses it to, whenever it's down, it will notify me. So that's, yeah, I really learned better production stuff with this. And another cool thing is the round robin deployment. I can just take out one machine, or I can just update code on one machine to see if it doesn't have too many errors. And then if it works, then I also deploy to the others. So it's a bit manual, but it's like, it has the benefits of a lot of things that you have full control over it. So the big question, what's the profit? So let's do another simulation, or let's look at the simulations. We'll use the time we have left for this. So this is some of the events I collected. There's 10 of them. Let's so this is kind of the data. I compressed it a bit for the demo purpose. What is interesting is we have symbol, and we can ask how many there are. There's 10 of them, so there's 10 different events. And you can see all the actual trades that happened on the exchange, so every single one of them and the time. So, but actually, we want to work with the aggregation of it. So, okay, wait, we'll keep it here. So we can actually aggregate it. And so now it's actually per 10 seconds. So actually, it's like this. So now it's aggregated per 10 seconds. That just makes it a bit more stable. And next, we want to look at just one example. So let's pick the first. So now we have selected only one event. We can actually plot it, the price. So this is plotting all the trades and how the price moved. So you can see here from around 0.06 to 0.14. So if you're able to buy at the start, this is the start of the event, and this is the sometime later. That would be, of course, amazing. So well, now let's go into a bit of the. This is adding Bollinger Band information. Let's let's add some information to these Bollinger Band. So I guess this didn't evaluate. Okay, so now I added some columns based on Bollinger Band. It's a technical technique. The purpose of it is actually to provide a relative definition of the price in historic perspective. So we can plot these. So let's plot the group. This is the normal price that we're now already used to. Let's plot the lower band and the upper band. So okay, so what you can see here is if the price really spikes up, then you could say, okay, the higher like the higher band also really goes up. And so what you can see here is that the more stable it is, the more narrow the band, like the less uncertain you are going to be about the price. So the higher the price jumps up and down. Like basically what you could say within this band is like a really high chance that the price will be. You will be very surprised if it suddenly moves out of it. It's possible, and you'll be surprised. And that's what you use actually for a technique trailing stop, it's called. So it's like a cumulative over the highest of the like things. So pretty much what this would mean, I guess we can better print it again. So this is kind of, so it's taking the upper of the lower band, and it's called a trailing stop. This is how you can implement it. Pretty much the moment it crosses this kind of line, that's the moment where you would sell. So you would buy here, you would sell there. Now I chose some 50 and 10 numbers, the magic numbers before, but this is something you want to simulate to find the best way to fit, for example, all these 10 coins. Like, I mean, I'm just drawing some random things here, just like the dinosaur before. Well, I prepared that. So here we have a simulation. It's, oh wait, actually, we can still calculate the amount of profit, so that's still an important step. So the buy price is when we would do like the first buy. So that's this. So this is the first buy price. Then you want to get the first time where they cross. So you can nicely vectorize this with pandas and get the first time that it crosses. So this is the index. But we also want to get the price, so that's this. So this is the price. So you can divide this by the buy price, and you have your profit. Now, using this result, we want to actually find the best parameters for this Bollinger Band. So that's here. You call them alpha and beta. You use the product of them, so it's like 10 times 10. Values that you try, and we're doing basically the same thing here to determine the gain per symbol and per the parameters. So it's like 10 times 10 times the amount of symbols of how many times we're actually doing this compared to just the one time I showed you, and so we're collecting results. And we can now sort them, and so what I'm printing here is the mean of all the coins per combination of alpha and beta. And so you can read this as, on average, we will have 20% profit on these events if we choose values of 4 and 3. So that's that part. So let's go to the key takeaways. Okay, this is no trading advice. Okay, I'm guaranteeing you will lose money, but it's still a really fun project. I mean, it's not all fun. I lost 20% on one trade by having a way too simple way of, okay, just sell everything off. It's pretty dangerous. Also, responding to a wrong event is very dangerous. But yeah, coding with this kind of pressure taught me some really nice tricks for production level. I mean, using a few $100 is no fun, and so it will stick with you. I've learned the benefits of introspection, centralized error logging, and a round-robin deploy. I always suggest you to do backtesting and favor a simple model, especially with finance. Don't think I'll just throw 1,000 variables in there, and then the model will magically figure it out. In the async land, once you go async, you have to go fully async, so the whole application should be asynchronous. So bear that in mind. If there's some part that cannot be done like that, then yeah, that's annoying. But luckily, yeah, at least for this project, everything worked for me in async. And actually, the Python async implementation is much better than you think, but you'll learn that from the trio after the presentation I showed you. And actually now is a better time than ever to get started with Async.io. So yeah, this was my presentation.